Survival at the top of the chain requires millions of years of physical evolution. But to dominate every ocean on Earth, the orca relies on the sophisticated hardware behind its teeth. The species functions through a highly convoluted, densely folded brain, an organ optimized for strategy rather than simple aggression. This chart shows the encephalization quotient, or EQ, a ratio comparing an animal's actual brain size to what we'd expect for its body mass. Even accounting for their massive bulk, orcas score a 2.57. Their brains are 2.5 times larger than the mammalian baseline. Inside that brain, orcas possess a highly developed paralimbic lobe. Biologists believe this extensive network of tissue manages intricate emotional information and the nuances of complex social interaction. This processing power is a biological necessity. Their prey has evolved nearly perfect physical escape mechanisms. Seals can haul themselves completely onto floating ice, and schools of fish scatter in thousands of directions at the slightest vibration. Defeating these defenses requires an orcapod to execute coordinated, multi-step tactical plays that outsmart both the target and the physical environment itself. Off the Antarctic coast, a crab-eater seal rests on an ice floe. Perched above the waterline, it remains out of reach of any predator's jaw. To reach it, a pod of orcas aligns in a strict formation. Swimming four abreast, they charge directly toward the ice slab. As they accelerate, the whales adopt a precise posture. They raise their heads, pitch their massive bodies upward, and angle their wedge-shaped tails down. By maintaining this angle, water flow stays attached, pulling it into a deep trough, a depression wave. When this moving dent reaches the slough, the front of the ice bends into the void, creating extreme mechanical stress. Pushed past its breaking point, the ice fractures and violently tilts, washing the seal directly into the waiting pod. The orcas never strike the ice with their bodies. They use geometry to shape the water into a tool, forcing the ocean's own physics to do the work. Thousands of miles away, orcas off the coast of Norway face a different mechanical problem. Atlantic herring are far too small and fast to be hunted individually by a 6-ton predator. The pod initiates carousel feeding. They swim in a wide, coordinated circle around a scattered school of fish, slowly tightening the perimeter. To panic the herring, the whales deploy sensory signals. They blow nets of bubbles and flash their stark white bellies. Driven by fear, the herring condense. They merge into a densely packed, churning sphere of thousands of fish suspended just beneath the surface. With the target compressed, the whales execute their finishing move. They turn and launch devastating tail slaps directly into the dense ball. The resulting shockwave stuns dozens of fish, making them easy to gulp down. By forcing the herring together, carousel feeding solves the problem of scale. The pod takes the prey's greatest defense, their numbers, and transforms it into a tightly packed weakness. An Antarctic orca does not inherently know how to herd herring into a bait ball. A Norwegian orca does not know how to snap an ice floe with a depression wave. These specific hunting plays are not innate genetic instincts. They are acquired cultural traditions, unique to specific geographic regions. These specialized tactics, along with unique vocal dialects, are taught by older matriarchs. This knowledge requires years of practice and social cooperation to master, and it is passed down through generations. Researchers recognize this level of group-specific, multi-generational cultural transmission as a behavior found only in orcas and human societies. A deep collective intelligence secures the killer whale's position as the apex of the global ocean, and they survive because their social structure allows them to turn the sea itself